Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for candy distribution problem. Let's look at the problem description. There are n children standing in a line and each child is assigned a rating value given in the ratings array. Okay, and we have to distribute the candies to these children as per the following requirement. The requirement 1 is each child must have at least one candy, and children with higher rating get more candies than their neighbors. We need to return the minimum number of candies that we need to have to distribute the candies to the children. Let's look at the example 1. There are 3 children. So for each children's rating is given in this ratings array. Okay. So the first children's rating is 1. So as per the first requirement, we give 1 candy to this child. And then the second child's rating is 0. But this also should have 1 candy at least. Okay. So when the moment we assign 1 candy to this child, because this child has higher rating, we have to give one more to this child. Okay, we have to give one additional candy to the previous neighbor of the current kid. And in the case of the third kid has a rating 2. Okay, because the second kid has 1 candy, they should be given 2 candies to satisfy the second requirement. So first kid get 2 candies, second kid get 1 candy, the third one get 2 candies. It's totally 5. So that is the output for this input. And in the case of example 2, there are 3 kids and the ratings for them is 1, 2, 2. Okay. So the first kid is given 1 candy and the second kid have higher rating than the previous one. So we have to give 1 extra candy than the previous kid. So 1 plus 1, 2. 2 candies will be given to the second kid. And the third kid has the same rating. So in this case, we don't have to give 1 additional candy, but instead we can give 1 candy to this kid. So if we give 1 candy to this kid, then we meet the first requirement. Okay. So this kid get 1 candy and this get 2 and this get 1. So totally 4. 4 candies we need to distribute to these 3 kids. The constraints for this problem are n is the ratings array's length and the n is ranging from 1 to 20,000. The value in the ratings array will be ranging from 0 to 20,000. Let's look at the approach to solve this problem. We are given this input ratings array which has 8 elements and the minimum number of candies required to distribute to these 8 kids is 20. Basically we can solve this problem using 2-pointer approach. In this case both the pointers travel in the same direction. They start from the beginning of the array and move all the way to the end of the array. Okay. So in addition to these 2 pointers, we need to keep track of few states as we process the ratings in the input array. Okay. So those states are the rating trend. Okay. So that basically which trend the current element is in, whether it is in the trending up state or trending down state or flat. In this case, first 4 elements are in trending up. They are keep increasing up to this point. Then it's trending flat. These 2 elements are same. There is a trend change here. And then from this elements onwards, it's trending down. So the rating is decreasing. Okay. So whenever we process an element, we need to keep track of whether the current element is in what trending state. Okay. Then the second thing is the down rating count. Okay. So when the current element is part of the downward trend, we have to keep track of what position that current element is in the trending. Okay. For example, in this case, if we when we process the element rating 3 and from here onwards it's trending down, right? So the trending count for this is 0 and for this element is 1 and this element is 2. Okay. I will explain why we need to keep track of the down rating count. And also we need to remember how many candies were given to the kid that was present at the end of the previous trend. For example, in this case, the first 4 elements are trending up and the 5th element is trending flat. So before we assign any candy to this kid, we need to remember how many candies were given to this kid. Okay, and also we need to keep track of the number of candies given to the previous kid. Okay, for example, for this kid we give 1 candy. Okay, and for this kid we have to give 2 because this kid's rating is higher than the previous one. Okay, so we have to give 1 extra candy than the previous kid. Okay, and when we process this kid, it has a rating 1 higher than the previous one. So this was given 2, so we have to give 1 extra, so this will get 3 candies and this will get 4 candies. Okay, so that's what this variable is, and this basically accumulate so far how many candies were given to the kids from the beginning to the current position. Okay, let's look at that input data in a graph. So the x-axis is correspond to the kids and the y-axis is the rating. Okay, so we can see from the kid at location 0 to 3 it is trending up and the candies given to those kids are increasing. For this kid 1 and this kid 2 and this kid 3 and this kid 4. So this is the reason why we need to keep track of the candies given to the previous kid in this variable. Okay, so when the rating is trending up, we simply increment this candies given count and assign that many number of candies to the current kid. Okay, and whenever there is a trending flat condition occurs, then only for the first kid we already given 4 and we don't have to give extra. Okay, so only if the rating is higher than the previous one we have to give extra, otherwise we don't need to give. So in that case we can give less than what we gave to the previous kid, and because we have to give minimal number of candies we can give only 1 candy to this kid. Okay, so that's why we reset the given count to 1 when it starts trending flat. Only the after the first kid, rest of the same rating consecutive kids will get only 1 candy. Okay, and in the case of trending down, we have to remember what position the current kid is in that trending path. Whenever there is a state change, we have to remember what was given to the previous kid, which was part of the previous trend. Okay, for example, this is the upward trend and this kid is the last one which is part of that. When we see this trending state change, then immediately we have to update what was given to the previous kid which was part of the previous trend. So in this case 4. So the given before state change variable will be updated with 4. Okay, and then immediately we see the trending down. So in that case again we reset that given before state change variable with the number of candies given to the previous kid, which is in this case 1. So that's why the given before state change variable is updated with 1. And also we have to give at least 1 candy to each kid. So we assign 1 to the given variable. And then we initialize the down rating count to 0 when we see the state change from flat to down or up to down. Okay, so in that case we have to set the down rating count to 0. So this is the first element in the trending down ratings. Okay, so after updating this, one thing we have to check. So we gave only 1 candy to this kid and this kid also should get 1 candy at least, right? But this violates the second requirement, which is if the kid has a higher rating, that kid should get at least 1 candy more than its neighbor. So this kid, when this kid gets 1, we should give 1 more candy to this kid so that the second requirements will be met. correct? How we detect whether the number of candies given to the current kid and the kid which is located at the end of the last trending, right? So in this case it is 1, and here if we add 1 to the down rating count and that value is equal to the number of candies given to the previous kid, then we have to increase the total candy count, which keep tracks of how many candies we have given so far, correct? So when we see the condition where the given before state change value is equal to the down rating count plus 1, in that case we have to increment the total number of candies given to reflect that was given to this kid, okay? And also we have to increase the given before state change count as well, because when we go process this kid, again we hit the same situation. This kid will be given 1 candy, okay? And because this kid has higher rating than this kid, we have to give 1 extra. This kid gets 2 and this kid also gets 2, right? But we have to satisfy the second conditions wherein the kid with the higher rating should get more than this. So we have to increment this also, right? So basically we have to add the down rating count to the total candies count, okay? So when we come here, the down rating count is 1. So when we come here, we check whether the down rating count plus 1 is equal to the given before state change, okay? So if that is same, then we have to increment the total candies count and we have to increment 1 for each kid present in the trending down as well as the kid which is part of the previous trending state, okay? So when we give candy to this, we have to increment 1 here and 1 here, right? So the down rating count is 1 plus the total. So if we add the down rating count plus the current given plus 1 candy given to the kid which is part of the previous trend, okay? So if we repeat that as we go down in the trending, as we trending down, we have to keep adding as many number of candies as the number of kids present in that trending down. So that's what I have written here. So basically we can solve this using the 2-pointer approach. First we initialize the total candy to 1. Previous and the current pointer will be initialized to 0 and 1. So the previous will be pointing to the first element and the current will pointing to the second element. And then the rating trend is first initialized with flat and then the down rating count is initialized to 0 and the given before trend change is initialized to 0. Then we start processing the rating pointed by the current pointer until it reaches the end of the array, okay? So if the entry pointed by the previous is lesser than the entry pointed by the current, right? So that means we are trending up, okay? But its current state may be different. So that's why we check whether if the current rating trend is not up, then set that trending to up. And then remember the given count in the given before trend change variable, okay? So whenever there is a trend changes, we have to remember the number of candies given to the last kid which was part of the previous trend. That's what we are doing here. And then we keep incrementing the given count because we have to give at least 1 candy more than the previous kid because the current kid's rating is higher than the previous kid. So this is for the trending up case and this is for the trending flat case where if the rating both pointed by the previous and the current entry are same, then we check whether the current trend is not flat. If it is not flat, then we set it to flat and then we remember the number of candies given to the last kid which was part of the previous trend and assign at least because we have to give at least 1 candy to this kid, so we assign 1 to the given count And this is for the trending down case. So if the rating pointed by the previous is greater than the entry pointed by the current, then we check whether the current rating trend is not down. If it is true, then we set it to down, and then we remember the number of candies given to the last kid which was part of the previous trend. And then we assign the down rating count to 0 because this is the first time we see the trending down. Otherwise, we increment the down rating count. This indicates the position of the current element in the trending down path. And then we assign 1 to the given count because we have to give at least one candy to the kid. So then this condition is for checking whether the candy given to the current kid is equal to the number of candies given to the last kid which was part of the previous trend. Okay, so in that case we have to increment 1 for each kid between the current kid and the kid which was part of the last trend. Okay, so that's why we increment the given before trend change variable and also the total candy variable, so that this reflects the candy given to the last kid in the previous trend. Okay, and then we have to add the given count to the total candy, and then we increment the previous pointer and increment the current pointer so that we process the next element in the ratings array. We repeat this until we process all the elements in the input ratings array, and finally we return the total candy. Let's look at the flowchart. Input for this procedure is the ratings array, and first we have to initialize the previous and current indexes, and then the count total candy given to current kid and rating trend, down rating count, and given before trend change variables. Okay, the count will be initialized with the number of elements in the array. Previous is set to 0 and current will be set to 1, and the total candy is initialized with 1 because the first element, the first kid will get at least one candy, so we initialize that, and then the given to current kid also initialized with 1. Okay, and then the trending is set to flat, and the down rating count is initialized to 0, and the given before trend change is initialized to 0. Then we enter the for loop, and first we check whether the rating for the previous kid is less than the ratings of the current kid. In that case we are trending up. First we check whether the current trend is not equal to up. If it is true, then we set that trend to up, and remember the number of candies given to the kid which was part of the previous trend. Okay, and we have to increment the number of candies given to the current kid, and then we add the number of candies given to the current kid to the total candies, and then increment the previous pointer and the current pointer to process the next element. So this is for the trending up, and this is for the trending flat case. Here also we check whether the ratings of the current and the previous kids are same. In that case we check whether it is the first time. If it is first time, then we update the rating trend variable with flat, and then remember the current given count in the given before trend change variable, and then we assign 1 because at least one candy we have to give to the kid. So we assign 1 to the given to the current kid variable, and then we add that to total candy and increment the current and previous pointer to process the next element. The last case is the trending down case. So in this case we check whether this is the first time we see the trending down. In that case we have to set the rating trend to down, and then assign the given to current kid variable to the given before trend change, and then we set the down rating count to 0. Okay, if we have already seen that trending down, then we simply increment the down rating count, and then we assign 1 to the given to current kid variable. This is to give at least one candy to the kid. Then we check whether the given before trend change is equal to the down rating count plus 1. This is to check the case where the first kid in the downward trend has the same number of candies as the last kid in the previous trend. So in that case, we have to give one more candy to the kid part of the previous trend. So that's why we increment the given before trend change variable and then increment the total candy to reflect that the now one additional candy given to the kid. Otherwise, we add the down rating count to total candy. This is for the case where we have to give one candy to each kid in the downward trend. Then finally we add the given to current kid count to the total candy and increment the current variable and the previous current and previous pointer. Then process the next element in the array. So once we process all the elements, we come out and return the total candy. Let's move on to coding. First I define the constant for trending types up, down and flat. Then I initialize the count variable with the length of the array. And then I initialize the previous pointer to 0. Next initialize the given to current kid variable to 1. And then the total candy also initialized with 1. And then the rating trend is initialized with flat. Then the given before trending change to 0. And then the down rating count to 0. Then I write the for loop. This processes the element starting at index 1 to the end of the array. There are three cases. Trending up case, where the rating pointed by the current is greater than the rating pointed by the previous pointer. The second is when both the ratings are equal. Third is a trending down case where the rating pointed by the current is less than the rating pointed by the previous. So in the case of trending up, first I check whether the rating trend is not equal to up. If it is not, that means there is a trending change. So we have to update the state. So I have updated that to up. And then I remember the candy is given to the last kid in the previous trend in the variable given before trend change. Then I increment the given to current kid variable to compute the number of candies to be given to the current kid. So I increment it. This is for the trending up case. Next is the trending flat, where all the ratings are equal in that range. So first I check whether the current rating trend is not equal to flat. If it is true, then I updated the rating trend to flat. Then I remember the number of candies given to the last kid in the previous trend. Next I compute the number of candies to be given to the current kid, because this kid is having the same rating as the previous one. We don't have to give the exact same number of candies. Instead, we can give only one, so that we can utilize minimal number of candies. So in this case, I assign 1 to the given to current kid variable. So I'm assigning 1 to the given to current kid variable. Then the last case is the trending down case. First I check whether the current rating trend is not equal to down. If it is true, then I update the rating trend with down, and then I remember the number of candies given to the last kid in the previous trend, and then I initialize the down rating count to 0, because this is the first time we are seeing the trending down element. This variable also help us to get the current element's position in the trending down path. So if the current trend is already in down, then I simply increment the down rating count, and then for the current kid we need to give at least one candy, so I assign 1 to given to current kid variable. And then next we check whether the current kid get the same number of candies as the last kid in the previous trend. In that case, we have to give one additional candy to that previous kid. So for that we have to check a condition where the given before trend change is equal to down rating count plus 1. If that is true, that means we hit that condition, so we have to increment the total candy. So if the given before trending change is equal to down rating count plus 1, then we have to give one additional candy to the last kid in the previous trend, so we increment the given before trending change variable and also the total candy variable to reflect that one additional candy was given to that kid. Then add the down rating count to the total candy variable. Next, add the given to current kid variable to the total candy count. Then increment the previous pointer. Then finally return the total candy count. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. We are given this input ratings array which has 8 elements and the expected output is 20. So basically there are 20 candies needed at least to distribute to these 8 kids. So first we initialize the count variable with the length of the array which is 8, and then the previous pointer is initialized with 0, and then the given to current kids variable is set to 1 to indicate the first kid was given 1 candy, and also the total candy also initialized with 1 to reflect that so far how many candies distributed, so only 1 candy. Okay, and then the rating trend variable is set to flat, and given before trend change is initialized with 0, and then down rating count is initialized with 0. Then we enter this for loop starting from the element at index 1. So in each iteration we compare the rating pointed by the current pointer and the previous pointer. So if the rating pointed by, in this case the rating pointed by the current is greater than the previous, so that means we are in the trending up state. So first thing we check, if the rating trend is not equal to up, we set it to up. So in this case it is flat, it becomes up. And then we remember the number of candies given to the last kid in the previous trend. So in this case the previous kid was given 1, so that is assigned to the given before trend change variable. Okay, then we add that given to current kid value to the total candies count, so it becomes 3. Then we increment the given to current kid variable to calculate the number of candies that needs to be given to the current kid. So in this case the given to current kid will be incremented, so it becomes 1 to 2. So this kid will be given 2 candies. Okay, then the given to current kid will be added to the total candy, so the total candy becomes 3. It was 1 and now it becomes 3. Okay, so in the next iteration the rating pointed by the current pointer is higher than the previous one. Again we increment the given to current kid count to 2 and then add that to the total, so this becomes 3 and that 3 will be added to the total candy 3, so it becomes 6. So in the iteration 2 again the rating pointed by the current is greater than the previous one, so we increment the given to current kid variable, so this becomes 4 and that 4 gets added to the current total candy, so it becomes 10. Okay, so in the next iteration the rating pointed by the current is equal to the rating pointed by the previous pointer, so there is a trending change, so it is changed from up to flat. Okay, so now we are in the trending flat case. So first thing we update the rating trend variable to flat and then remember the number of candies given to the last kid in the previous trend, so which is 4. So that's why we remember that in this variable. Then we at least we have to give 1 candy to this kid, so that's why the given to current kid is initialized with 1 and that gets added to the total candy, so it becomes 11. So in the next iteration the rating pointed by the current is less than the rating pointed by the previous, so it is a trending down case. So we have to remember the number of candies given to the last kid in the previous trend, which is 1. Okay, so we are now in the trending down case. So first thing we check is whether the current rating trend is not equal to down. In this case it is true because it was flat earlier, now it is set to down. Then we remember the number of candies given to the last kid in the previous trend, so that was changed from 4 to 2. Actually it was 1 and because of this calculation it becomes 2. Let me explain that. So assuming we gave 1 candy to this kid, that means the given before trend change supposed to contain 1 and then we initialize the down rating count to 0. So down rating count to 0 and then the given to current kid is set with 1 because at least we have to give 1 candy to this kid, so that's why it is assigned with 1 and then we check the condition where the candy is given to this kid is equal to this kid. In this case we have to give 1 more candy to this the previous kid, so that's what we are doing here. So if the given before trending change is exactly equal to the down rating count plus 1, then we have to increment the given before trend change. So that's why it becomes 2. Initially, when the state change happened, it was 1, but because of this condition, it becomes 2. And then the total candy is also incremented to reflect the additional candy given to this kid. Okay, so the total candy becomes 12, and in addition to that, we have to add the candy given to this current kid. So that's why the 11 plus 1 candy given to this kid and 1 candy given to this kid. So that's why it becomes 13. And in this iteration, again the rating pointed by the current pointer is less than the previous one. But in this case, it is already part of the trending down case. So we simply increment the trending down count. So it becomes 1 to 2. And then we initialize the given to current kid with 1 because we have to give at least 1 candy to this kid. Okay. Then we have to check whether the given before trend change is equal to the down rating count plus 1. So in this case, the down rating count plus 1 is equal to, they both are same. So we have to increment the given before trending change variable. So it becomes 3. And then the total candy we have to increment. So 13 plus 1, 14. And then the down rating count is 2. Right? So 14 plus 2, 16. And then the last iteration, again we see that rating pointed by the current is less than the rating pointed by the previous. So we increment the down rating count. So from 2 to 3. And then the given to current kid is initialized with 1 because we have to give at least 1 candy to this kid. And then we check whether the given before trend change is exactly equal to down rating count plus 1. So in this case, they are matching. So we have to increment, in this case 2 plus 1 is equal to the given before trend change count. So we increment both the total candy and then the given before trend change. So 16 plus 1, 17, and then the down rating count is 2. 17 plus 2, 19, plus the given to current kid 1 is added. So it becomes 20. After processing all the ratings, the total candy has 20. That is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity for this solution is order of n. Okay, let's take the case 1 where the ratings array has 8 elements. Okay, so in this case, how many iterations this for loop performs? So it starts from index 1 all the way to the last element in the array. Okay, so this for loop starts from index 1 all the way to the end of the array. So for this case, it performs 7 iterations. Okay, if there are n elements, this for loop performs n minus 1 iteration. Removing the constant factor out, the time complexity for this solution is order of n. Space complexity is order of 1 because there are no additional space allocated here, only few variables we use to process the ratings array. So the space complexity is order of 1. Thanks for watching this video. Have a great day.